Hello friends, this lecture is in continuation with your online lecture series of CNC machines and automation. In the last lecture we have discussed about the MCU and its elements. Now today we are going to discuss about the three major topics of the CNC machine, which is must and very important in terms of your examination point of view and in terms of learning point of view. Correct. The three main topics are NC coordinate system, then the rules of axis identification in CNC machines, and PLC. So what is NC coordinate system? NC coordinate system is simply your X, Y and Z system, because whenever you are going to give the command to a CNC machine, then you have to specify which axis it has to move, X axis, Y axis or Z axis. But keep in mind that these X, Y and Z are not same as the Cartesian coordinate system. Correct? Whether it is X, Y and Z, but it depends, it varies according to the machine to machine, that which axis is Y, which axis is X and Z. Clear? So it is depending upon machine, what type of machine you are using. Clear? So axis identification. We are discussing now in this lecture the three linear axes. We are discussing only the linear axis. We all know that three linear axes are three types: X, Y and Z. Correct? So X, Y and Z, how do we identify? It is not simply the rule of that if it is horizontal X, perpendicular to X is a Y and perpendicular to both is Z. It is not like that. It is depending upon machine, whether your tool is rotating, workpiece is rotating, and neither of them is rotating. Here, in the mechanical, we are having three types of machines, whether rotating workpiece, rotating tool, or no rotating workpiece, no rotating tool. So in these three machines, we do not know that which axis is called what. It is not a certain rule, but there are some rules through which we can define the axis in all the different machines. It is not certain that which the lathe is having the x-axis, the same is having milling machine. No, it is not the rule. Correct? It is not the way. But to identify any axis, that's why it is called axis identification. To identify any axis in a machine is a task, and it is depending upon the rules. So in today's lecture, we will discuss about the rules of those. Correct? So firstly, the z-axis, which is called the z-axis or z-axis. That is the axis of main spindle. There are various spindle of the machines can be there, because it is nowadays we are having multi-spindle machine. So whichever is the main spindle, that will be called as a z-axis. Like in simply your lathe machine, your job is rotating, so the spindle is that. Clear? In your milling machine, your tool is rotating. In that case, that is your z-axis. Fine. So the main spindle axis is always called z-axis. The positive z-axis, so z-axis is further of two types, positive and negative. When the tool is moving away from the workpiece, that is called positive z. Correct? If the tool is moving away from the workpiece, that is called positive. If the tool is coming towards the workpiece, that is called negative z. So what about the x-axis? X-axis is further, we can identify the axis through three different rules. Fine. So the first is, it is always horizontal. So the first case is, it is always horizontal. So the x-axis would that axis in which it remains horizontally. Here, second part of this is called parallel to the holding surface. So the first is always horizontal, second is parallel to the holding surface, and third one is the longest axis of movement of workpiece. Correct? In which the workpiece can move the longest. Workpiece or tool can move the longest. That will be called your x-axis. To define or to identify x-axis, there are three factors which we need to take out. The first one is, it should remain horizontal. The second one is, it should remain parallel to the holding surface. And third one is, it should be the longest axis of movement of workpiece or tool. Correct? So that will be your x-axis. We'll discuss different types of examples in which you can prove that x-axis is which one, z-axis is which one. So we'll discuss that. So what is the positive? It is defined as being to the right. So whenever you are watching from the spindle side, and then if the tool is moving right side, that is your positive. If the tool is moving left, that is your negative. So what is y-axis? Y-axis is perpendicular to both x and z-axis. Fine. So y-axis is what? Perpendicular to both x-axis and z-axis. That will be your y-axis. Fine. Then rotary axis in the machine. In today's topic, we are not covering this rotary axis, but yes, we all know that this is the direction of the rotary axis. When your thumb is impressing to one direction, correct? When you curl your finger, wherever the thumb is going, that is your direction of rotation. So in the machine, we are having three rotary axis even. Rotation about x-axis, rotation about y-axis, and rotation about z-axis. Fine. 3 linear axes and 3 rotary axes are there. So this is the first case in which you can find it out which one is the x, y, and z axis. So it's a vertical milling machine. Fine. So it is a column. It is your column which is rotating. Everybody has seen this kind of vertical milling machine. So it is rotating. So the main spindle is this. So it is your z axis. Moving downward, it is towards the workpiece. That's why it is minus z. It is away from the workpiece. It is positive z. Then x-axis. Why it is x-axis? Because the first condition, it is horizontal to the surface. Fine. Then the second condition, it is horizontal. The second condition is it should be the longest axis. Fine. See, the longest axis. The workpiece can move the longest axis. And third one is it is parallel to the holding surface. This is your holding surface of workpiece. So it is parallel to your workpiece. Fine. So the three conditions are verified. And perpendicular to both x and z is the y-axis. Clear? So it is very well defined. Then this is your horizontal milling machine. Everybody has seen this is your horizontal milling machine. So your horizontal milling machine, this is your tool rotating, correct? So this will remain your z-axis. Okay, very fine. This is your z-axis. Then the x-axis. Again, it's the longest axis of movement. Plus, it is parallel to the horizontal surface. It is parallel to the holding surface, and it is horizontal. So x-axis is defined. And why it is y-axis? Because it is perpendicular to x and z. There is a simple rule for y-axis. If it is the direction of perpendicular to both x and z is always your y. So it is your y-axis. Now the third case, it is a simple lathe case. So in this case, you can see the positive and negative side of both. See, this is the x and z axis only, because there is no y-axis. We all know that the machine do not move in the y-axis. So it is negative. This is spindle direction. This is spindle rotation. Fine. So this axis would be your z-axis. Fine, very fine. Then this is your x-axis. Why it is x? Because it is parallel to the holding surface. Secondly, is the longest axis of movement. Fine. And so this is your, why it is positive x? Because when you are looking from the your spindle towards the workpiece, when you are looking from the spindle towards your tool, then the right side is your positive, left side is your negative. So all three conditions of x-axis and one condition of z-axis is defined. That's why it is identified. The x and z-axis are identified. And the lathe machine do not move in the y-axis. That's why I have not shown. This is your non-rotating workpiece, non-rotating tool. So in this case, this is your maybe your shaper machine. This is your slaughter machine, in which both are not revolving. But how can we define this x and z and y? So this is why it is x-axis, because your tool can move up and down. This is your tool. We hold the tool over here. So tool can move up and down. That's why it is your z-axis. It is moving away from the workpiece. That's why it is positive. Down towards the workpiece is negative. So it is your holding surface. Okay. This is your holding, and it is the maximum size. First condition. It is. It should be of longest distance. Fine. It should be parallel to the. It should be horizontal. It is horizontal. Thirdly, it should be parallel to the holding surface of the workpiece. So the workpiece is holded over here. It is parallel to the holding surface, and perpendicular to both x and z is y, positive. Right. So this is how we can define the x, y, and z axis in any CNC machine. And it is not same. You have seen through the various examples. It is not same in all of the machine, correct? It is changing, so we need to identify it. It is not a certain rule which can apply on all the machine, correct? Now the next topic is PLC. PLC is the most basic part of the CNC machine, without which the CNC machine cannot work, without which the CNC is not a CNC. Clear? So what is PLC? It is short form of Programmable Logic Controller, correct? So it's a microprocessor based special computer, correct? It's a small computer which can monitor and adjust processing. Monitor means to check. It is always check. Monitoring means checking, and adjust the processes. Adjust according to the environment. Adjust according to the conditions of the process. Fine. So what are the components of a programmable logical controller? It is a very small computer. You can see over here. There's a processor. It's a central processing unit. Correct. It does not have any monitor. Very fine. It is having one input module, one output module. There's a one power supply, there's a programming device. Fine. So input module is from the sensors, correct? From the sensors in the machine. I told you there's a feedback devices which is called the sensors. The input is from the sensors, correct, which sense the things from the various transducers or sensors are available in the CNC machine. Then it process it, correct? Then it process it. Processing and verifying through your programming device. Clear? You input the program into it, correct? It gets the output, the input from the sensors and gives the output according to the program and according to the feedback from the different sensors. Clear? And then there's an output module. Output module, your contactors, then your solenoid valves, then your alarms. Fine. Through the different sensors, it can take the input and to the different output channels like your actuators, like your solenoid, like your motors. It can move these kind of things. So it required a power supply. You might have seen that there's a in and out arrow for the programming device. Fine. But in this case, every arrow is towards the processor and out of the processor, but it is two-way arrowhead. Why? Because this is the major important part of the PLC, that you can do n number of time program it. It is not like once you program you cannot change it. You can change n number of times. Here, that is the benefit of this PLC controller. It can use in various machine and it can perform various functions. Just change the program. Just change the program and you can use it to any machine. Fine. Then, what are the features of the PLC controller? The first one is internal utility relay. Relay is, it's a time delay, correct? When you want to stop something for some frequent, fraction of time or maybe some longer time, this relay are to be used. Like in your bulbs, like in your festival bulbs, correct? They are having a different pattern. And how you set the different pattern? This is a small microprocessor chip is used in there, and using that microprocessor chip for a larger purposes, that becomes your PLC, and it is having internal utility relay. It does not exist physically and nor receive signals from the outside world. It do its work internally, correct? It do its work internally. It is sometimes called on and off time. Then there's a counters. Counters means to count pulses, correct? How many, like your energy meter, the meter that is installed at your home outside, correct? To count the number of how much electricity you consume. There's always a blink. There's always a blink. That's a pulses, correct? That's a counter. That how many counts you did that, how many times you did or you perform this function. Here, it does not exist physically. We have not seen the counters in our energy meter, but yes, it exists, and it count pulses. So PLC having other features to count the things. Then there's a timer. Timer means in how much time you can do this process. This is simply a timer. A clock is internally built in the PLC. Then there's a data storage. Very important, very simple task of this PLC, that it can store the data. N number of times you program, you can store the data inside the PLC. Then there are the advantages. There are a lot of advantages of the PLC. Without PLC, the CNC cannot even exist. Clear? Even if it exists, it cannot work properly. Right? So it is a maintenance and diagnostic. Very good in maintenance. It can tell you which part is faulty directly, and very flexible. I told you that it can do n number of programs. You can change the program, use it for any purpose. Correcting the errors. Even if you are correct at some point, it will make you correct. Large quantity of contacts are to be made. You can see in this image there are large quantity of contacts are made. Low cost, high speed of operation, reliability and simplicity. Correct. Documentation can be maintained. Fine. Then how many programs you have run till now, how many products you have manufactured, which process is to be used. So this kind of documentation can be made into it. Then the security. Nobody can hack it. Okay, because it is completely offline thing, so you cannot hack it. Then it is easy to reprogram. There are so many. This PLC programming is a very vast area for the further your career, that you can pursue your career in the PLC programming. Fine. There are the disadvantages. In India, there are some disadvantages because this is newer technology. Very simple. It's newer technology. Nobody wants to change it. Clear? Secondly, fixed program application of fixed circuit operations. It means not economical to do single operation. Those industries in which the various operations are to be maintained, then this kind of a PLC programming could be used. If you are doing one operation all the time, need not to have it because it is not economical. Then environmental consideration means you have to maintain the room air conditioned, as we discussed earlier, because of this PLC factor. I told you to your CNC room would be properly air conditioned so that your PLC could work easily. Then a fail-safe operation. Fail-safe operation means if it has to choose between a machine and itself, it will choose the machine. It means it will make itself damaged to save the machine. That is called fail-safe operation, right? So your PLC would be damaged but without damaging your machine. That is the fail-safe operation, correct? So this is all about today. If you wanted to subscribe my channel, the link is provided in the description of this video, and make sure that you have watched all the previous videos, and for the further videos must check this channel. Thank you and take care.